welcome to DDR's YouTube channel. In this one, we're going to take a look at the recent announcements regarding the Performance Linked Incentive Scheme (PLI) scheme for battery technology. World over, there is a push to go green, that is, move away from petroleum products for transportation and towards electric automobiles. Thanks to massive improvement in lithium-ion battery technology and companies like Tesla, there is now a movement towards electric vehicles by all automakers. China has made major investments in this field by cornering, mining, processing, and establishing massive battery production and recycling companies. We'll take a look at the global scenario at the end. You can now contribute to DDR's efforts at bringing you the latest in aerospace and defense indigenous development by contributing through UPI. We really value all your contributions. Thank you for everyone who's contributed so far. You could also join the DDR community on YouTube right here by clicking on the join link in the description below. Don't forget to hit the subscribe button and the bell notification icon to be notified every time we post a new video. But India is a late player. India's oil imports have ballooned over the years, and high oil prices, as we are seeing right now, cause a lot of pain. Yet the Indian market is rather price sensitive, and hence electric vehicles would need a big subsidy push to get going. For this, the government had rolled out the Performance Linked Incentive Scheme aka PLI for new battery plants. The program envisaged an investment which will boost domestic manufacturing and also facilitate battery storage demand creation for both electric vehicles as well as stationary storage, and at the same time development of a complete domestic supply chain and foreign direct investment into the country. The Advanced Cell Chemistry PLI scheme hopes to translate into a net savings of nearly 2 to 2.5 lakh crores in oil import bill and increase the share of renewable energy at the national grid level. In response to an RFP released by the Ministry of Heavy Industries in October 2021, 10 companies had submitted their bids. In the first tranche, Reliance New Energy Solar Limited, Ola Electric, Hyundai Global Motors and Rajesh Export Limiteds were selected to receive incentives which amount to nearly 18,100 crores towards a cumulative capacity of 50 gigawatt hours per year. Their manufacturing facilities would have to be set up within a period of 2 years, and the incentive will be disbursed thereafter over a period of 5 years on sale of batteries manufactured in India. Let's look at each of them now. Reliance New Solar is setting up a 5,000-acre, 100 gigawatt facility called the Dhirubhai Ambani Green Energy Giga Complex at Jamnagar in Gujarat. The technology? Well, they've acquired Lithium Works, a lithium iron phosphate or LFP solutions company. That is, they do not use cobalt in their batteries, including their patents, manufacturing plant in China with a capacity of 200 megawatt hour annually. They've also acquired a UK-based company called Faradayon for nearly 1,005 crore rupees, which has a patented sodium-ion battery technology. They've also acquired NextWave, a German company, as well as REC Solar and Sterling & Wilson for solar cell production. They've also acquired a Danish firm, Steensdal, for developing hydrogen gas production. We've recently seen Union Minister for Road and Transport, Nitin Gadkari, ride a Toyota hydrogen car, while Reliance aims to get into the hydrogen-powered cars business too. They've also acquired Ambri Inc., an energy storage company based in the US. Like always, Reliance seems to be going big. Ola Electric, the electric two-wheeler company, has taken a strategic share of an Israeli battery technology startup, StoreDot. So looks like the batteries that they will be making in their giant production complex in Hosur, Tamil Nadu, will be based on Israeli tech. Hyundai, a major global car manufacturer, has a wide range of electric vehicles worldwide already, and they plan to introduce around 6 new electric vehicles in India. They've used LG Chem batteries earlier, and they have set up a battery plant with LG Chem in Indonesia recently to take advantage of Indonesia's nickel refining capability. Indonesia is a global giant in that field. Hyundai has also tied up with another Korean battery maker, SK Innovation, to provide batteries for their Kona EV. One of these companies is expected to be the battery maker for Hyundai's Indian plant. LG Chem and SK Innovation are top-ranked global battery suppliers alongside Panasonic, Samsung and Chinese companies Cattle and BYD. The fourth winner, Rajesh Exports, is a Bangalore-based jewelry company. They've been silently working on an EV pivot for a while now. They aim to build batteries in commercial vehicles like buses and passenger vehicles like cars in a facility in Karnataka. Let's see how they shape up. From the posts on LinkedIn by their employees, they seem to be working on the entire chain, including their electric drivetrain. There are lots of these startups coming up, so let's see how they shape up. Apart from the first tranche announcements, bids by Mahindra and Mahindra Limited, Exide Industries, Larsen and Toubro, Amar Raja Batteries, and India Power Corporation towards a cumulative 43 gigawatt hour capacity has been waitlisted and might be greenlit soon. Apart from these companies, there are companies like Tata Chemicals and Suzuki who are also expected to begin their lithium ion battery making plants in the near future to cater to their own EV product lines. So, where does India lie in the global battery capacity? Chart by Benchmark Mineral Intelligence makes it abundantly clear. Currently, there's a total of nearly 1000 gigawatt hour production capacity, and India's is barely minimal. In 2 years, all of these companies whose bids have been accepted will have to start production. And assuming the electric vehicle industry grows by 26 and the other companies also begin making their own batteries, we are seeing nearly 200 to 250 gigawatt hour of production in India out of a total nearly 3000 gigawatt hour production worldwide. Will it be enough to cater to just India? Maybe. But are we comparable to everybody else in the world? Certainly not. But the point to ponder here is that it will kickstart lithium-ion battery production as well as domestic R&D, and hopefully in a few years encourage R&D within India by Indian companies. As you can see, China has a vast lead over all other countries when it comes to battery manufacturing capacity right now. And while it is forecast to reduce due to rapid capacity expansion in Europe and the US, it still will maintain a healthy lead in 10 years' time. Batteries are just one segment of the whole EV industry. The government expects this PLI scheme for advanced chemistry cell amounting to nearly 18,000 crore rupees, along with the already launched PLI scheme for automotive sector amounting to 25,000 crores, and FAME, which is nearly 10,000 crores, to enable India to leapfrog from traditional petroleum based products to an environmentally cleaner, sustainable, and more efficient electric vehicle based system. Earlier, military industry research and development on the back of giant government funding would lead to new wondrous products for the civilian market as offshoots. Times have changed now, and it is the civilian industry that has the scale and spare capacity to provide cheap, efficient, and advanced technologies to militaries worldwide based on products developed for the civilian market. A giant domestic civilian industry developing new technologies if the military has to keep pace and outclass its opponents. Lithium ion batteries are being used by militaries worldwide in diesel electric submarines in place of older lead acid batteries and fuel cells to enable longer endurance apart from other advantages. Permanent magnets using rare earth elements now form a vital part of brushless DC motors that power everything from hard disks to toys to drones to missile actuators. Producing magnets for EV motors will also enable production of motors for submarines, destroyers, and frigates for the Navy, which is now aiming to switch to electric propulsion for their next generation surface and subsurface fleet. The materials that make up the battery are therefore key for not just the civilian side of things but also the military side of things. The Indian government and the Australian government have signed an MOU just recently to enable mining and refining to making lithium ion as well as other new green technology. In a later video, we'll take a look at what are critical elements and minerals needed for future technologies.